All right, 3 goals for today. The first will be to find the pressure reading for these 2 pressure gauges on this tank. Second is to decide whether it is gauge or gauge. And then third, for this YouTube manometer, find the height of mercury that you would see over on the right-hand side. This problem has a tank which contains a mystery fluid that is part liquid, part vapor. It's connected to a YouTube manometer which has mercury on the other side, which is then exposed to the atmosphere. The pressures that were given for the vapor pressure and atmospheric pressure are both absolute. This means that they are in reference to absolute zero, whereas 0 kPa absolute pressure is like outer space. It's a complete vacuum. Now, the way pressure gauges work, they actually measure a relative pressure. They measure the difference in pressure between 2 sides. Nearly all pressure gauges that engineers use, whether it's a cheap little tire pressure gauge you use on your car, or a more expensive board-on tube that you would use to measure pressure in a tank, you're going to be measuring the difference between the pressurized system and atmospheric pressure. And this distance is gauge pressure. So gauge pressure is a relative pressure, how much above atmospheric pressure you are. And if you're below atmospheric pressure, that is vacuum pressure, where vacuum pressure is essentially the same thing as gauge pressure, it's just negative instead of positive, because vacuum would be below atmospheric and gauge pressure above atmospheric pressure. So vacuum pressure doesn't mean that it's at absolute zero or that it's below absolute zero, it just means that it's below atmospheric pressure. So the pressure in sensor A is just going to be the difference between the vapor pressure inside the tank and atmospheric pressure outside the tank, 20 kilopascals. Boom, and just like that, a third of the way done with the problem. The pressure point B is going to require a little bit more work because you can see that point B is actually connected to the liquid, not the vapor, and we aren't given at the beginning of the problem what the pressure is at this point. So using the hydrostatic equilibrium equation, that is delta P equals rho GH, we can find that the pressure of the liquid at point B is going to be the pressure of the vapor plus density of the liquid times gravity times this change in height, which we can see is 1 meter. We find that this is about 129 kilopascals. So this change in pressure due to the liquid is about 8,800 pascals, since a Newton meter per second squared is a Newton, and a Newton per meter squared is a Pascal. That requires a unit conversion because the original pressures were given to us in kPa, kilopascals. So after doing some unit conversions and subtracting atmospheric pressure, 28.8 kilopascals would be the reading on that pressure gauge B. All right, so the big question, is it gauge or gauge? You'll probably almost always see it written as gauge with a U. And almost all the time when referring to actual physical hardware, actual things, the measurement devices themselves are almost always used with a U. Most textbooks are going to spell it with a U, and it's still kind of rare, but usually when you see gauge without the U, it's just going to be referring to gauge pressure using gauge as an adjective. Neither one is wrong, it's just that the one with the U is far more common, and this one is more rare, so if you use this one, people might think you're wrong sometimes. The spelling with the U is overwhelmingly more popular. If you're not sure and don't really care, just spell it with a U. Now, dictionaries are descriptive, not prescriptive. They're supposed to tell you how we use language, not how we should use language. But out of curiosity, I decided to look up this gauge versus gauge just to see what the dictionary says, because sometimes they provide good historical references to where words come from, and that may help figure out which one you should use. So Merriam-Webster has this note down at the bottom of their definition, where they're trying to tell me how I should use this word. All right, now bring it in for a second. You can't live your whole life just doing what the dictionary tells you. So with that, I'm Team Gauge with an A. Fight me in the comments. I use it for gauge pressure, I use it to refer to the devices themselves, and ultimately, if you would like to gauge my interest as to how much I actually care which one to use, it's pretty close to 0. If you think your professor's going to care that much about it, go ahead and spell it with the U, but Indy here, your TA, he likes the version without the U, just the gauge, so I'm Team Indy, Team Gauge, A only. Let's get back to the video. All right, last step, let's solve this manometer problem. Indy wants to play, so we got to get going. So I start off by labeling some relevant points on the drawing. Point 1 and point 2 are both the vapor pressure that we were given. Point 3 is the pressure of the liquid that we already solved for that was used for the relative difference in pressure sensor B. And conveniently, point 4 is exactly horizontal from point 3. So since there's a continuous section of fluid, this mystery liquid, from point 3 down through the little loop-de-doos up to 0.4. 0.4 and 0.3 are at exactly the same pressure. So to find the pressure 0.5, it's going to be the pressure 0.4 minus rho GH for the mercury. We're subtracting pressure due to the mercury because as you go deeper in a fluid, you increase pressure. Going shallower in a fluid, you decrease pressure. Since 0.5 is exposed to the atmosphere, we've got 101 kilopascals on the left-hand side of this equation. The right-hand side, we've got that 129 kilopascals from before. And now we use the density of mercury, gravity. This is 9.81, not 32.2, since 9.81 is metric units, 32.2 is for English units. And the last unknown is going to be H. We get a final value for height of 0.216 meters. And as you can see by this question mark tail curl, your TA Indy approves. This is a TA approved answer. Thanks for watching and enjoy the rest of your day.